Hello, I'm going to focus today's video on how do I extend students' knowledge to include the secant-to-secant relationships. So if I start off where we left off before, looking at inscribed angles and the relationship that we know about those inscribed angles. So we know that we have two chords here, C, E, and C, D, that are on the circle. And my students will know, since they're on the circle, that they can find the angle of angle C, and then they could actually put also a line in here. Actually, I want to make that a segment line from point D to point E and get the measure of this triangle. So they can get the measure of E and they find the measure of D. And I think they will already understand that, knowing what they already know about triangles and so far with inscribed angles. And then they also know that they could get the arc measurement, so that this arc D all the way here to E. I apologize, I still haven't learned how to do the colors yet. That arc is half of this angle C, and then they can still find the measure of D and E, because both of triangle DCE have to equal to 180. So if they know these two, then they will also know, they'll be able to figure out what D and E is. So using all of that we talked about before, and moving on to how are angles different. Let's look at this particular example, where in this example, we're looking at, well, how are the two images similar? What is different about them? And trying to make the connections with the lines or the line segments inside the circles, which are chords, and then bringing that back to what they already know about lines and circles. And now that these lines that intersect a circle are called secants. And so I know that my students as eighth graders won't know that word secant. It will mean nothing. But describing the word, and hopefully they'll come up with their own definition by the end, is part of the focus. And so looking at that would be my question to them, is what is similar, what is different about these two? And they will notice that they will say, well, this is a line that intersects with this circle B. Whereas here, the lines, I could extend out these lines and then they will look similar, but right now they're a line segment. And so if I could make triangles inside here to find where what angle C is and what angle D is and what angle E is, similarly, I would think that I should be able to do the same thing. So if I wanted to find what the angle of F is, it should be very similar to how I found out what angle C is, just looking at the similarities. And then also this one is a little bit different, just where the point G and H land on the circle, but other than that, it does land on the circle, so it's similar in that part. And then having students identify all these similarities to see how they could do the measurements. So then if we look at also looking at all three of the angles, then what are similar and different about all three? And what do they notice is different about all three? Um, and that will lead to the discussion. Well, oh, I see that these lines are on the circle. Um, they are crossing through the circle. They're not, none of them are crossing through the center or the center of the circle, but they're all are crossing through the circle. And so there's a point, I can find a point on the circle and another point on the circle. And they cross through the circle. Um, and noticing the difference is where they intersect. Do they intersect on the circle, outside the circle, and inside of the circle? I think students will be able to see that. And then being able to use that information of how much is this arc, subtracting this arc will give me the angle of angle A. And that they will be able to build to that over time.